and how to use some of the tools that I've given you. So, okay, multiplication. What's the purpose of multiplication? When it was first developed, why? Who cares?
To like repeat. No.
You're there. One more word, Bosco. To write repeated.
I don't remember the numbers, but two, like 2 plus 2.
Addition. Yes. Multiplication is repeated addition. So I think in elementary school you call it skip counting. If 3 times 2 is effectively the same as 2 plus, yeah, I'm going to write down both of those. 2 plus 2 plus 2, this pen is terrible, I need to get rid of it. But it's also 3 plus 3. Either you have 3 groups of 2 or 2 groups of 3. At the end of the day, and the result there is the same. 2 2s is 4 and another 2 is 6, or 3 plus 3 is also 6. The result is the same. It doesn't matter which way you slice it. But that is the purpose of multiplication. It's to shortcut addition. Likewise, if you're multiplying and one of those values is negative, it's no longer repeated addition, it's repeated... No. Thank you. Subtraction. Multiplication does not give you repeated division, Dea. But thanks for the enthusiasm. And then the number gets more negative. So if I have 3 times negative 2, that's 3 groups of negative 2. So I'm going to have negative 2 plus negative 2 plus negative 2. So things getting more and more negative. Negative 2 plus negative 2 plus negative 2. Negative 6. And if I have negative 3 times 2, that's the same as having 2 groups of negative 3. Same thing. Negative 6. The result there is the same. You've seen it before. Multiplication can be written with a few different kinds of notation. It can be written as a number next to a bracket, or with the x between. So you have 3 times 2. That's what that x symbol means. Or 3 butted up right against a set of brackets. You can write it this way. We don't write it this way. Even though it's technically not wrong, don't do it. But there's other ways to write it too. You could put them both in brackets. That's better than this. And then what's the other notation for multiplication? A dot. You betcha. One day you will learn that these two, 3x2 and 3.2, right now they're both what? Right now they're both multiplication. The result is 6. You will learn one day that these are not actually the same kind of multiplication. But that will not be today. For today, we will assume they are the same. And then anything multiplied by 0 is 0, because you have no groups. So if you have, or you have 3 groups of 0. Okay, if I have 3 groups of 0, that's going to be 0 plus 0 plus 0, which is 0. Or the other way to look at it is, instead of having 3 groups of 0, I have 0 groups of negative 222. It doesn't matter how big this value is. If I don't have any groups of them, I don't have anything. The result there is still 0. Don't want to do this yet. No. And then there's rules for multiplying negatives. What are they? Or should we do them on the next page? Some of you are confusing the multiplication rules for negatives with the addition rules for negative. What does that mean? That's like 6, 7. Keep change. Means nothing.
Change the sign, and then you change the last number to like a positive or a negative. Right?
Does it? If always, just for fun? So give me an example. So this is one of my deepest frustrations with middle school. at perhaps elementary school, wherever you learnt the trick. Some of the tricks are nice, like when we're thinking about like, okay, how do I divide by a fraction? We'll do that in a couple days. But when you've got something like keep, change, and you're struggling to explain why it is the way it is, let's be really clear here then about what you're talking about. So, if I have a positive number times a negative, if we think about what the definition is, that's these guys up here. A positive times a negative is
Negative.
this many. It's negative because it's this many groups of a negative value. If I have a negative times a positive, it's the same thing. I have the positive number of groups of the negative value. You're adding a bunch of negatives together. Both of these results are going to be negative. The positive times a positive is easy. Positive times a positive should only ever be positive. But a negative times a negative, it's also positive. But why?
Because the negative would cancel out.
But why? But why?
The same thing.
Right? Like the same, but different. It's like, and this is to try and avoid the tricks, and then you screw up the tricks. Like I still have grade 11s and grade 12s are asking like, should I cross multiply here? Should I not cross multiply here? If you just knew how to do the math, we wouldn't be having this conversation about when to cross multiply and when to not cross multiply. So developing a bit of a deeper understanding is something I want to do, and we're going to do that on the for this one. We're going to do it on the next page, but we're not going to do it. Yeah, we'll do it on the next page in a second. So the multiplications tables, something you want to memorize. If you haven't got those things locked in, we've got your multiplication table here. You're welcome to use it, but you know, the quicker you can lock these things in, the better off you'll be. So 13 times, no, let's go up here. 3 times 3, 3 groups of 3? 9. You could skip count your way there because the numbers are small. 3 and 3 is 6 and 3 is 9. You can memorize that math fact, or you're having a rough day. You pull out your multiplication table because thinking is hard. First block on a Wednesday, second week back at school. And for those of you who have never seen, maybe it's been a long time since you've used, the things that you multiply together, multiplication is what these things are designed for. I want 3, and they meet in the middle at 9. 3 groups of 3 is 9. 3 times negative 3. Positive times a negative is going to be negative. And 9. Negative 3 times 0. Anything times 0 is? 0. So then this one's 0, too. I have no groups of 6. If I have 7 groups of negative 5, it's going to be negative. And then 7 5s is 35. 5 7s is not obviously 35. But it's easy to skip. It's hard to skip count 7s. But it's easier to skip count 5s if you're in a jam. If I have 3 times negative 2, we've done this one already. No, we didn't. It's going to be negative because one's positive, one's negative, and 3 groups of 2 or 2 groups of 3 is 6. We're going to review longhand multiplication because in a moment of desperation, it can be useful. Though the table does go up to 20 by 20. So you don't have to necessarily be able to do all the long multiplication, but you know what? It's a useful skill. Let's review it. So 13 times 2. If I'm going to review this, multiplying by longhand, I got to stack them up. How do you multiply 13 by 2 longhand? Eve, your hand was first. So 2 and the 3 is? And then the 2 times 1 is 2. Okay, cool. Why? Why does this work? Why does long multiplication work this way?
That's how
Because that's how it works. Okay, if you understand some of the techniques, though, all of a sudden, it can unlock some powerful ways of doing math in your head. So does anyone, Dad, do you want to explain why this works? You put up, your hand was kind of on its way up a second ago.
It works because because like 2 times 13 equals 26. So if you multiply the 3 and the 1 separately, and then you put the 1 in front of the 3, you get the right answer.
Somewhere in the middle. You neither cooked nor got cooked. Okay, let me show you why. Yes, Bosco?
You multiply them separately once and then tens and then you put them together.
There it is. So it comes down to how we've been looking at things before. That's why place value is so important. Because what is 13? 13 is just 10 plus 3. If I take 13 and I multiply it by 2, that's the same as taking 10 and multiplying it by 2, and 3 and multiplying it by 2, and then adding those results together. 2 times 10 is easy, it's 20. 2 times 3, you guys said already, is 6. And then 20 plus 6 is 26. You can break up, and especially when you're multiplying larger numbers, being able to recognize that this is actually what you're doing. You're breaking 13 up into 10 and 3, multiplying each piece by 2, and then recombining them. That's what longhand multiplication is actually getting you to do. So if I have 13 and 5,
65.
you're correct. It is going to be 65. How did you do 6 times 12 plus 5, or how did you do it? Or did you do?
5 times 3, 5 times
Okay, so 5 times 3 is
15.
15. Okay, so where do we put the 1 from the 15? Yeah, you add it to the tens.
2,
Then 5 times 1 is
50. Plus.
plus.
6.
See, and this is where students get confused. Like, why am I adding that there? But it's 5 times 1, which is 5, but it's 50, so it's 1 plus. But if you think again, break it down. What are we actually doing here? 13 is 10 plus 3, and multiplying 13 by 5 is the same as multiplying 10 by 5 and 3 by 5 and adding those results together. 5 times 10 is 50, 5 times 3 is 15. Those math facts are a lot easier to come to. And then you add those two results together. 0 and 5 is 5, and this is why we add the 5 and the 1. Because 50 plus 10 is 60, and we get our 65. Being able to keep that straight in your head and recognizing why it is the way it is can open up some powerful mental techniques. Yes? It is. How'd you do it?
I did 10 times 13 plus 13.
Ooh. So you changed this thing. You said, okay, it's going to be 13 times 10 plus 13 times 1. And you added those two results together. You betcha. So that's going to be 130. That's going to be 13. You add those together and you get 143. You bet. That is a way to break this thing down. So now, because you've broken it down that way, I want to go back and look at it the other way. How are we going to go back and do it? How do you do 2-digit by 2-digit longhand multiplication? Dea?
So you put 1 times 3, which is 3, do 1 times 4, which is 1. Then you put like an x, you put an x below the 3.
Why do you put an X?
When you do multiplication, it's like you split it, you skip a space, like the first value.
You're right,
It's because
but you're not. But you're right, but you're not. Does anyone put, so Dea says you put an X down below the 3. You can do it that way. There's something else that you could put down here too.
Dots.
A 0. The 0 is actually the better result. Why is the 0 the better result? Because now
it's not confusing.
well, we're not multiplying by 11 now. We've multiplied by the 1 like you did here, and now we're going to multiply everything by 10. When you multiply by 10, it starts with a 0. So it comes back to what we're actually doing. How are we breaking apart longhand multiplication? Put the 0 down there. And now you're just multiplying 13 by 10. 1 times 3 is 3, 1 times 1 is 1, and you add those two things together. It's the same result. We're just not writing it this way. But this is what this means. 3 plus 0 is 3, 1 plus 3 is 4, and 1 is 1. So you get 143. Last one. 13 times 13.
167.
Yes, it is. You just memorize the perfect squares?
No.
No?
Okay.
How'd you do it?
13 times 10, 13 times 3, and then
And you added those results together? So 13 times 10 is going to be 130. 13 times 3, 3 times 3 is 9. 3 times 10 is... I mean, we could break this thing down further if we wanted to. And add those things together. 1, 6, 9. If you don't want to write it out that way, and again, you don't have to break it down this time, but I wanted to show you what we're actually doing here. For those of you who have perhaps forgotten why longhand multiplication works. 13 times 13. 3 times 3 is 9. 3 times 1 is 3. Add the 0. You can add it that way. This is why the algorithm works. 9, 6, 1. And we get the same result. This is why multiplication works. Okay, when you're ready, flip the page. Let's talk about negatives again. Using Pac-Man, because who doesn't love Pac-Man? Fun fact, Pac-Man wasn't always called Pac-Man. Pac-Man was originally called Puck-Man, but then the Japanese guy who invented Pac-Man was scared about what the Americans would do to the name Puck-Man for obvious reasons. So they just changed it to Pac-Man. Fun fact. Okay, here we go. Multiplying two negative numbers gives you a positive number. You said this on the previous page. But why the frig is that true? Sometimes it's easy to accept, you just roll with it, but I want to give you a justification for why that is the way it is. And the justification that I'm going to give is I'm going to take those positives and negatives and connect them to an idea about direction. So we're going to use Pac-Man here. Pac-Man can move forwards. We'll say that movement forwards is positive and that movement backwards is negative. But he can also face the negative direction, which we're going to call left, or he could face the positive direction, which we're going to call right, because that's how you label a number line. So it's going to be a combination of which way is Pac-Man facing and which way is Pac-Man allowed to move. So if the two numbers are positive in this example, the thing I'm trying to break down here for you, if they're both positive, that means Pac-Man is facing to the right, and he is going to move to the right. And on this labeled number line, that means he's moving in a positive direction. He's going to move 3 groups of 1 in the positive direction. 1, 2, 3. There he is. 3 times 1 is 3. Positive, which you all knew. But I'm setting up a bigger justification for what's coming. Now we've got Pac-Man. Now he's facing left. That is what this negative is trying to symbolize here. Pac-Man is facing to the left. And now he's facing left and he's going to move forward, facing that direction. He's going to move forward 3 times. Moving forward, facing left means he's going to go 1, 2, 3. Here we are on the number line at -3. So far, so good? Or very quiet on a Wednesday morning. 3 times -1. Now the other one's negative. He's facing the positive direction. But now this negative means he's going to move backwards 3 times. So this is now the direction. Well, he's moving backwards, but facing positive. So if you're facing forwards and moving backwards, you're going to go. It's going to go left again. 1, 2, 3. 1, 2, 3. Here he is, down at -3. Using the analogy for direction, then I think I like how this turns out. If I multiply a negative and a negative here, what is he doing? Well, he's facing backwards. Sorry, no. He's facing left. But now he's going to move back. If you're facing left, and moving backwards, both of those are negative ideas. The moving backwards is negative, the facing left is negative. But if you move backwards and you're facing left, which way are you actually going? You're going to the right. So you end up moving in a positive direction. Your movement is negative because you're moving backwards. The direction you're facing is negative, but the end result is a positive value. It's one of those ideas that doesn't really work when you think about it being groups, because you can't have a group of a negative number of things. You can't have negative numbers of groups of negative numbers of things. But when you think about negatives as being related to directions, which way are you facing and which way are you moving, I think the justification for why a negative times a negative is a positive. I think it becomes a little bit easier. Flip the page. When you talk about multiplication, we also have to talk about division. Division is just fancy multiplication. Believe it or not. What makes division fancy multiplication? You're not using regular numbers anymore. You're using fancy numbers. What's the other F word we use when we're talking about fractions? There they are. Love it. Division is just multiplication involving fractions. That's all it is. Division is multiplication with fractions. Layla, good morning. If you could live in another city, what would be the city you would want to live in? Any city in the world. Vancouver is a city. Okay, division is the process of sharing of an equal sized groups. That's wording is terrible. I screwed something up in there, but that's okay. So if I have 6 divided by 3, what that means is I've got 6 divided into 3 equal groups. If I'm going to take 6 and I'm going to break it up into 3 equal groups, how big is each group? 2. Each group has to be 2. I mean, if you wanted to break 6, we could break 6 all the way down into 6 ones and start portioning them out. But if we don't have to do that, so much the better. 6 divided by 3. So then what that question is actually answering is, how big is the group that I broke 6 up into 3 times? So then the result there is obviously 2. It's one of those 2s. Or if I've got 9 pencils and I want to share them equally between 3 people, how many pencils is each person getting? 3. Got to be careful with the number 3 when you're using your fingers to demonstrate the number 3. Share 9 pencils between 3 people. Every person's getting 3. Division is also expressed as a fraction. Okay, the symbol for division looks like what? What is the symbol for division? What's the symbol for division? A line with 2 dots. But if you look at that symbol, it looks an awful lot like, as Dea just said, a fraction. There's the bar across the top. You just don't know. These dots represent an unknown numerator and an unknown denominator. But at the end of the day, that division symbol is just representative of you're working with fractions now. Surprise. So if I have 15 thirds is what this says, this is the same thing as 15 divided by 3. And that is, of course, 5. For fun, I want to show you how to use the multiplication table for division. How do you go backwards on the multiplication table? Obviously, it only works for numbers that are nicely divisible, but here's how you'd use it. We have to go to the table, and you want to find, for this example, you want to find the numerator. I want to find 15. That's a little bit harder to do, but not impossible. 15 is either right here or 15 is right there. Is that the only place 15 shows up on the table? Yeah, I think so. So then to figure out what the result is when you take 15 and you divide it by 3, you want to make sure that the 15 you grab is in a 3-row or a 3-column, which it is. Both of them are. And then you look at the other value. If I want 15 divided by 3, I got 15, I got 3. That's not the one I want. I want that guy there. 15 thirds is 5. That's how you'd use a multiplication table to do that if your mental math game is, if you are not confident in your mental math game. That's how you use the table. So it's important to recognize what happens with 0. What does 0 divided by 3 mean? What am I asking you to do with 0 divided by 3? You want to divide 0 into 3 groups. You want to take nothing and you want to split it up into 3 groups. How big is each group going to be if you started with nothing? It's going to be empty. And the numerical representation for that is 0. The fractional representation for 0 divided by 3, the first one's always the numerator, the second one's always the denominator, so it's going to be 0 over 3. You want nothing divided into 3 equal groups is still nothing. And for those of you who are interested in the history of math, the concept of nothing and turning that into the number 0 is a really fascinating story. I had to write an essay on the invention of 0. Thank you, India, for giving us 0. I discovered. Because for a long time, there was no numerical representation for nothing. You just had nothing. Because where did math start? What was the purpose of the development of mathematics at the very beginning of time? No, why? Why did people decide to invent math? Accounting. You have things. I would like to buy things from you. If you have nothing to buy, we have nothing to talk about, which is why 0 wasn't originally a thing. But then eventually, Indian mathematicians and financial wizards decided 0 was necessary. The Greeks tried, but they got scared of 0. That's another story for another time. Here's the other one. 0 divided by 3 means I want to take nothing and divide it into 3 groups. Those groups are all going to be empty. What does this mean? I want to take a known value. I want to take 3. And I want to divide it by 0. Yeah. I want to take 3 things, and I don't want them in any groups. If I leave them alone, they're in one group, right? If I just take my 3 sheep, and I put my 3 sheep over there, that is a group of 3 sheep. But what does it mean to take my 3 sheep and to divide them into no groups? But then I have 0 sheep. I still want my sheep, but I don't want one group. I want no groups. Keep my sheep. It doesn't work. Like, back at the foundations of mathematics was accounting. It was, I'm buying stuff from you. And so this is undefined. Dividing something into no groups is an undefined operation. Because it doesn't make conceptual sense. And there are things in math that don't and are allowed to just be, you know what, we just don't do it because it doesn't work. Is effectively what that means. Sometimes if you put it into a calculator, you'll see one of 3 messages. You'll either see UND, which means undefined. That's one of the things your calculator will say if you punch this into your calculator. Other calculators will say error, because that's the easy way to just say that something's wrong. You've done something wrong. This is a you problem. Or some calculators are barely more helpful, and they'll tell you, well, you've actually made a math error. Shocking. But those are the things your calculator will tell you. It does not make conceptual sense to divide a known amount of things into no groups. Long division by hand. The thing that everyone hates in grade 4. How do you do it? Who remembers? Who can talk me through? Yes, sir. Long division by hand. The what? Sorry? Like that? Okay. Yeah, so the thing you're dividing by goes on the outside. The thing that you're dividing goes into the inside, you betcha. Okay, so 2 divided by 2 is 1. And you check that you're done by actually remultiplying it back out, right? Like when you say, okay, 2 goes into 2 once, so then 1 times 2 is 2, you subtract, you get nothing. There's nothing left once you've done that division. And then 2 times 2, you bring down the 4. 2 times 2 is 4. There's nothing left. So you've actually succeeded now in dividing 24 up into 2 groups. Those groups are then 12 big. I mean, long division sometimes breaks down. Does long division work with this one? Does it? Well, Dea, you...
No, it doesn't.
Why not? You said it did, now it doesn't?
3 is bigger than the first number.
So let's write it out. Yeah, 3 is bigger than the first number. Here's my long division. Like, 3 doesn't go into 2. So then I have to say, okay, well, what's 3 into 24? Which is what the original question was anyway. And at that point, you're just either pulling out a math fact or you're pulling out a multiplication table. If you're going to use a multiplication table, let's find 24 on here. Let's just make sure we're cool with how this one works. 24 is there. 24 is also there. 24 is there. So which 24 do I want to use? Because you know what the answer is? I mean, the short answer is yes, but no. That's not how you want to justify this. Which 24 do we use? We found a bunch of 24s. What are we dividing 24 by in the question? 3. So you want the 24 that's either in a row or column based on the 3. Like we could have picked this 24 down here too. This one would have also worked. You want the thing that you're dividing by, the thing that you're dividing, the 24, to show up in the row or column of the number you're dividing by. So 24 divided by 3, and then you go to the other value is 8. So long division totally breaks down here. There's no point in doing long division here. But it works on this one. Ow. 91 and 7. Let's do it one more time. I am not going to make you do a law of long division, just so we're clear. But it's a useful skill to review because it shows up again, believe it or not, when you're dealing with something called polynomials. You guys did synthetic division, right? When you did polynomials?
I never did.
You haven't done long division with polynomials? No, but did you do synthetic, or is that coming up year 2? Did you do the remainder theorem? Yeah, it's coming up this year. Okay, so let's divide 91 by 7 longhand, and then we're moving on. How many times does 7 go into 9? Once. So you put the 1 up top, and then 1 times 7 is 7. How much do we have left over? We've got 2. We bring down the 1, so now we want to go 7 into 21. Does that work nicely? Yes. How many times does 7 go into 21? 3 times. There's still some math facts that are necessary here. 3 times 7 is 21, so this is a nice little division. There are no remainders. There's no decimals. 91 divided by 7 is 13. Comments, questions, concerns about long division? Okay. I want you guys, in a second, we're almost done, but not quite, to do these bottom 3 as part of what I'm going to assign to you for homework. And I want you to demonstrate for me long division. Even if you don't have to do it long division, I want you to show me the algorithm. I want you to show me that you know the steps and can do them. Some of you will be able to crank these out in your head. That's not the point. Show me the technique. Okay. Before you do that, I got one more page for you here. Multiplying, dividing rules, we already talked about them. If I have a positive times a positive, that's positive. If I have a positive times a negative, that's a negative. If I've got a negative times a positive, that's a negative. And a negative times a negative is positive for the reasons Pac-Man tried to share with us. But what if I'm multiplying a whole bunch of numbers together? What if I got like 3, 4, 5, 6 numbers in a row together? What do I do with positives and negatives there? So like something like this guy, I've got 31, 14, and 91. Without even multiplying all of those together, is that result going to be positive or negative?
Negative.
I heard 2 different answers. Which one of you is right?
8.
Dea?
For 8. For 8.
Yeah, for 8.
Because it's 3 negatives. That's odd. So it's going to equal a negative.
Why?
Because we're technically doing negative 31 times negative 14.
Okay, so and we said earlier that a negative times a negative is?
A positive.
Okay, so those two multiplied together are going to give you a positive value.
But then we have the negative 91, which a negative times positive equals a negative.
So we can break it down. We can say these two negatives are going to give me something positive, but then this one negative times the positive result from here is going to give us a negative value. You betcha. So can we extend that? Dea, you did. You said if I have an odd number of negatives, it's going to be negative. Why is that? Well, because if you have an odd number of negatives, you can pair up the negatives, but there's always going to be one left over. You betcha. So an odd number of negatives will always give you a negative value for that reason. So then positives, an even number of negatives, those two are going to give you something positive. These two are going to give you something positive. And now all of a sudden we're multiplying a positive by a positive. Positive times a positive, you guys all said earlier, was easy. That's going to give you a positive value. So I want you to include this page too. I don't want you to actually, so for these ones, I do want you to find, without a calculator, I want you to find that product. This is part of your homework down here too. And you can do them all by hand, or there are actually nice, slick ways to do these questions. I'll do one of them for you. I'll do the hardest one. I'll do I for you. Use these positive, negative rules up here to simplify your work. How many negatives do I have down here at the bottom?
5.
I got 5 of them. So that means my answer has to be negative. So just at the outset, toss that negative there once you've established that your final answer is going to be negative. And now we don't have to worry about it. Now we can just go ahead and multiply everything else together. 5 times 2 is 10. Multiplying by 1 doesn't change anything. 10 times 1 is 1. 10 times 1 is 1. 10 times 10. 10 times 1 is 10. 10 times 1 is 10. And now I want to go 10 times 2 is 20. And I had that negative that I tossed out there before because I've got an odd number of negatives being multiplied together. So what I just demonstrated for you is what I'd like you to do down here. There is a missing bracket in letter H. My apologies. H should look like that. Should be a bracket in between there. But I want you to go ahead now and crank out a bunch of multiplication and division questions. This page I would like you to do. I will walk around and help. These 3 I want you to demonstrate long division for me. And then if you flip the page one more time, there are 38 multiplication and division questions, and I would like you to crank them all out. On your mark, get set, and go.